right now that's
I
probably
don't
an
know. She's playing the
elective.
next 4 years of my life for me.
Candy.
Yeah, she wrote.
All right, first things first, we got to talk about Monday because very soon we're going to be losing a couple of our classmates to Mr. Gacka. All right, so homework. Homework. Pick 6. Okay, whatever 6 you want. Do not. Well, I mean, obviously I'm telling you pick whatever you want, but my advice is don't just pick the ones that look easy. First off, if you do 6, you're going to end up doing a couple of difficult ones. But try to push yourself. Make sure that you're testing. Do I understand what I'm doing? We're going to start on 82 from yesterday. We're going to quickly try to finish that stuff up, and then we're going to go into the final lesson of Chapter 7. Monday, for those of you that are going to be at Thomas Worthington, we will be doing the Chapter 7 closure. So
we're gonna come back like at 1, so we'll have like a little bit of
summer
class.
class. So we are going to be working through these problems, working on proofs, some conditional probabilities, some algebra, some exponent work, just a lot of general review of the year, factoring polynomials, which you've been seeing some of this stuff on your homeworks. Using zeros, there's been a couple questions on your homework about using zeros to figure out what the quadratic or what the trinomial is. Completing the square, so all that sort of stuff. So if you are gone and if for some reason you don't make it back here, check out the video. We'll be working on for you.
That's gonna be me.
If someone from KMS attacks us, then you'll know.
KMS is gonna attack.
All right, so read all of the information here. Do not start making your table before you read all the information. I want to see where we're at with making these two-way frequency tables and answering a few questions. So I'm going to give you like 5 minutes to dive into this on your own. I will come around if you need any help. I can check in the smart
I
file.
got home at like 10.
Sorry, I'll write down both of those, so I'm going to take pictures.
10:15.
84, 89.
To practice with the piano. It was stressful.
We did start 722 yesterday. We're wrapping it up.
We were on 82.
82. Number 82. So I'm writing your homework up on the board.
Alright, we'll write 82 on the I'm continuing off my old notes.
Good morning. Please pardon the interruption. For any of our 8th grade boys interested in Wolves baseball, the open gym for the 5th has been canceled. The other open gyms are still on. That's Wolves baseball for 8th grade boys. Thank you.
Isn't today for exactly 4 years from now supposed to be a Tuesday?
What?
What?
Oh.
Why would that matter?
February 2nd, 2022. It should be
Oh, because
Tuesday.
you're trying to look at 2222. Sure.
And it's a Tuesday.
That would be
So it's like the ultimate Tuesday.
That would be
Yeah.
great.
I've heard about this before. He's not
making here. I'm looking back at this.
But it's
So, but that's completely off topic. Do you have your two-way frequency table? Have you calculated these probabilities? I love cool mathy days.
cool.
But we're working on this right now.
Cool and good. Probability tables can't wait.
Can't. Vital.
They're vital.
That is not very vital. This one.
Right? I thought it was like you can't create either.
So the information we know is boy, girl, some have, some have not. Hopefully you
Okay,
have
if
this.
I did the boy go up top.
That's fine.
Okay.
Yeah, if you're flipped, you just have to flip everything. 14, 9, 23, and 7, 18, and 12, and out here, your class total. If that is exactly what you did, wonderful. But we're going to go back and change this table. Now, if you have space within your table, feel free to put the probabilities within the table that you have. But we now are going to make a probability two-way frequency table. So, kind of like what we did yesterday with the farm game. I can't remember what it was exactly called.
Make a farm. Oh, build a
Build a
farm.
farm.
You remember it.
Connor's favorite game, Build a Farm.
Yeah. I just built this. Make it for Discovery Day. Yeah, you should.
Make a farm? All right, so if we fill in this table of probability, what is this really representing then? Our 100%. So if we start with fractional form, what probability would go in boys that have gone? 4/30ths, right? Or 2/15ths. And fill in the rest of this. What is the probability that the person chosen has already presented?
7/30.
7/30ths. Has not presented. 23/30ths. Is a girl. 12/30ths. Is a boy. 18/30ths. If we wanted to, we could also set this up in an area model. We could, yeah, we could tree diagram this. So, what is the probability? I mean, this is pretty easy. He selects a boy who's already presented. Or no, we already answered that. What's the probability? That's why I said we're going to move through this quickly. So what is the probability that they're a girl or they've already presented? How do we deal with or probability situations?
It's the probability of the one thing happening plus the probability of the other thing happening minus the probability of both.
Yes, if you double count it. So it depends on how you do your addition. So, like Ava said, or situations then actually add. The and situations do what with the probabilities? If the or adds, what do the and do?
Multiply.
Yeah, they multiply. Or adds and multiplies. So the probability of or, girl, or presented previously is now going to include all. Ooh, went too far. It's going to include this and that.
And the bottom right.
And the bottom right.
Yeah.
Girls. So you can do.
So why did Ava say I have to do a subtraction?
Overlapping.
Because if I just straight take the probability of being a girl, 12/30ths, add it with the probability of having presented 7/30ths, we get 19/30ths, which has counted this region twice. And we don't want to, because that region does not get counted twice. So we could take the 4/30ths, 3/30ths, and 9/30ths, and then what would we get? 16/30ths. So either add the individual regions, or if you add like the column row, you then have to subtract for the double counting. That, in case we forget, is called over counting. Even though we're like calculating probabilities, that in itself is called over counting. You've done something else. So if the student previously presented, that is our assumed or our given, what's the probability that they are a girl? Colin? 3/7. Because the people who have presented, our total group is now the given, our girl group is the feed. Any questions on that? Let's try to make an area model for 83. Let's try to make an area model.
Oh, I mean, this is easier because it's percentage points.
And it's not like a 52.7. It's
Like,
pretty.
Now, Ethan, this would work on graph paper pretty well.
yeah.
Too good. I'm hungry.
Wait, isn't this one of the ones that it's like... I don't like this problem.
This is like the one where you guys told me we needed more information. We really didn't.
I don't think we need more. Oh, God.
Well, depends on how you set it up. How? Somebody tell me how you want me to set this up. Just like this. Okay.
Wait, if they're not working, oh, wait,
Come on, parents, do something good for your child.
What if they're like letting her do something better? Whoa.
I don't. Well, she needs math and she needs to work somewhere.
What if they're trying to get her like an internship?
Okay, you know what? Oh,
You don't really need math very well.
that font is really weird.
Unless you want to be a math teacher. Or like going to engineering. Exactly. If you're not smart enough, you don't want to do something hard.
Ooh. So when I said somebody tell me how to set this up, and you said exactly like this, does the work and study at the same time? Does that region make sense?
No.
Like, so if she works, she can't study.
Wait, and if she,
So that's what this says.
and if she doesn't work, then she has to study. But if she doesn't work, then she can't not study.
So is this really my two-way frequency? No. Okay, so if I leave my study no study, then what's the other thing? Well, not pass fail.
A or B.
A or not A, right?
I mean,
Transfer.
you know, you need to get an A's passing test.
Now, how do we determine the probability that she studies? What does it hinge on, Colin?
It's what it was based on what her parents told her earlier that 50% chance she would get to study.
Okay, so they told her there's a 50% chance you have to work, which means there's a 50% chance you will study. So if I was on graph paper and I made this 10 wide, 1, 2, 3, 4, 5, okay. 50% chance I can study, 50% chance I will not study. If I study, what's my chance I get an A? 80%. So 80% of this, well, because I had to make a rectangle, this is 6 tall. 80% of that's just over 75.
4.8.
You're going to go right about 80% of...
No, 4.8 squares.
Oh.
How big 80% of it is.
I think 4.8 is too much.
I just did that on my calculator. 6 times 0.8.
Oh, okay, yeah.
No, it isn't. I wish it was.
Because is there an 80% chance she gets an A if she doesn't study? No. So that line has to stop. It does not continue all the way over. What's the chance she gets an A if she does not study? A 10. So this is still my not A region. This is my A region. This has to add up to 100%. Does 80% and 20% add up to 100%? Does 10% and 90% add up to 100%? Yeah.
Wait, 90?
10 and 90.
I thought that was 10.
So the question is, what would actually go in here?
If we were going simply based off of what the chances are for given A or A for that side, it would be 80%. But since we're doing it times times 1/2, it's going to be 40% of the whole.
That A is 80%, but this then becomes 40%, but this A is not 80%. This A is 10%. So this conditional probability is affecting the probability of one of the outcomes in the table, because my probability of getting an A is not consistent across the table. It changes depending on whether I study or not. So then this becomes 1/20th. In the realm of me taking this test, there's 5% or a 20th that I don't study and get an A. Right? That's what that rectangle is not studying and having an A. There's a 5% chance.
That's a very low chance. I would not take it.
What goes in this box over here?
Wow.
1/10. What goes in this box?
0.45.
If I look at this being 0.05, if I add them all up, I should get 100% from the inside of my table. And I believe those values are correct. That's a lot of books.
Thanks.
Alright, so now let's say that she just wants to know what's the probability that she's going to get an A.
45%.
How do you know?
I added 40% and 5%.
Yeah,
And I
it's
got
just the
45%.
two reasons. So that's an or, right? That's an or.
Not an
A from studying or A from not studying. Assuming she gets her test back and is handed it back and gets an A, what's the probability that she studied? If we now know she got an A. Chris,
8, 9.
how do you know?
Because of the 4/10 over the add. So 4/10 over 4.5 tenths, which is really weird. So it ends up at 4 over 4.5 in the end because of cost, because of division of fractions, and then I just put it back up to 8.
Yeah, that's our region where she got an A, right? That's now our total since that's our given. So the probability that she studied, given that she had an A, 4/10 over 45 tenths, or 45 hundredths, sorry, which is much simpler to deal with as a fraction, 8 tenths. Any questions? All right, let's look at the next lesson.
I'm having the urge to ask you to take the mouse cursor off that area because I feel like it's highlighted because of the mouse cursor on it, even though it's not.
Thanks for the document reviews.
Basically, if you hover your mouse cursor over something, it usually like highlights or shows the glow kind of on the screen.
So Letitia,
And
right?
that
We're gonna
utilizes
fail.
so much of it.
Letitia, that's me.
So remember, CPM presents real data. I think a lot of times they
A
cite
last night for the homework, how many did we have to check?
Hmm?
For the homework last night, did we have to do all of this?
Did you look at
the
the homework?
84 through 88.
Yeah, we didn't do 90 through 90.
Yeah, that's all I assigned was 84 through 88.
Thank you, though,
You're
for
welcome.
that, because I did not want
Or
to.
sorry, 89. No, didn't
You
I
were
say
fine
88?
89.
All right.
I don't know.
Maybe I meant 89. I don't care. Stop at 88 if you want.
I got 89, that's what I had to say.
All right, so in a recent survey of college freshmen, 35% of students checked the box next to saying they exercise regularly. Some of them were probably lying. 33% checked the box next to eat 5 servings of fruit and vegetables a day, because really, if you're being healthy, you should be eating 5 meals. And 57% checked the box next to neither. Create a two-way table to present this data. And then try to answer these questions. I'm going to give you a few minutes. We're in here till 38. So we got a good amount of time. We got like 20 some minutes left. Sorry, I'm putting it on the TV.
You can do the 59 through.
Mr. Johnson. I know it's like fruits and vegetables. I'm just like abbreviating. What do I fill in where as I start building this?
Put 57 in the bottom right, and
You
100
put 57.
like 100 in the bottom right.
So, okay. So are you just working in percents? You're just going to give me numbers. But, so you said bottom right being here, you put 57? So Ryan put 57 for the no exercise, no vegetables, because that's your neither. Right? They said no to both. What else? 33 at the top right, here or out?
The right. And then 35 in the bottom left. And you can just do add up to the middle ones. Get 65 and 67 for
Okay, so I need to, sorry, this is a bad notation thing. Either we're working in percents or working in decimals, don't mix. So, sorry, I had a decimal up there. So you're saying you found this as 67. What about this? Is everybody with me on how we found the 67, 65?
Yeah.
The vegetables have to add up to 100%. The exercise has to add up to 100%. Now, back into your table, we can fill in everything else. Because if 57, and we could actually just imagine this was 100 people, 57 of them, no vegetables, no exercise. How many, no exercise, but do eat vegetables? 8. That's weak. So they make good food choices, but bad, lifestyle choices.
Well,
How many people here in no vegetables, but do exercise? Which means how many people up here?
25.
That would be 25.
So, let's make sure we totally understand this conditional. What is the probability that they exercise or eat fruits or vegetables? So we're going to group these students into like making good choices. So they exercise or eat those fruits and vegetables, the proper servings. How do we find that or? Ethan?
You just add up everything except for the no vegetables and no exercise to get 43%.
Correct. We add up all the boxes aside from neither. And surveys do that. Like they figure out how can we spin this data to make it sound better than it is, or make it sound worse than it is. Do you think there's a correlation here based off what we see?
If you know that like someone exercises, it changes the probability.
Ethan?
It kind of seems like if you do one, you're more likely to do both.
If you do one, you're more likely to do both. So think about the probabilities with the given situations, right? What's the probability that I eat fruits and vegetables given that I exercise? What's the probability that I exercise given that I eat fruits and vegetables? Those are going to be very high. There's going to be strong probabilities. Compared to what's the probability that I eat fruits and vegetables if I do not exercise? So that'd be like 8 out of 65. That'd be really low. What's the probability that I eat fruits and vegetables if I do, or sorry, what's the probability that I do exercise and I don't make healthy food choices? 10 out of 35. That's going to be very low. So yes, there's a correlation. Yes, there's an association here, because when you look at those given probability standpoints, some are much stronger, some are much weaker. Does that make sense how we look for association? Look for the differences in the given situations, those conditionals. Look at 99. I'll try to get you guys some homework time. So we are going to play this game twice. So we want to remember how to do two-way frequency tables when we do something twice. So try to draw a diagram, and I guess you could tree diagram this if you wanted, but I like frequency tables. We need to figure out what's the probability that Nick wins. Not this exact one.
We've done stuff similar to it.
We've
We've
done
done double
some
spin before, but not.
It says, remember the game from chapter 3.
If we're doing different
I think
things,
we've
like
used this game board.
raising different things, Gunner, it's a completely different game.
You can only do so many fractions, right?
Do you
So
not know
many
your
dollars.
CPF?
They're repeating the game board, but it's a different series of questions. We're using it differently. What makes you win? Who has actually read? Getting the same thing twice. So there's multiple ways we can win. how'd you guys build your table? Did you go up by dollar amounts, up by probabilities?
I did mine by dollar.
Oh, you're going tree diagram. If I did this, I'd probably go like 1, 5, 10, 100. I made this a 10 by 10, but I'm kind of regretting that. Because if I think percentages, I'm thinking 10 by 10. But in this situation, what would be an easier table to make? 8 by 8, right?
Yeah, I made that mistake.
It's slightly wider than it is tall, and it's killing me. So the 1 region gets 3 wide, right? It's 3 eighths. The 5, 2 eighths. The 10, 2 eighths. And the 100. If I do the same thing working down, 1 gets 3, 5 gets 2, 10 gets 2, and 100 gets 1. How then could I talk about the total here for the probability? I want to make my life really easy. Because, like, we for a long time teach you guys, always reduce if you can, always work in lowest. There's some situations where we don't really want to work in lowest terms or reduce. Like, we want a common denominator to make things easy. What should my denominator be here? 64. If I go all the way down here to spinning 100 and spinning 100 again, you have a 1/64th chance. And that means my common denominator, if I want to make life easy, should be 64. If I've used graph paper, this is simple to fill in. How many squares?
Good morning, Gabby and team. Please stop by the office for a moment. Gabby and team, please stop by the office for a moment. Thank you.
Literally, they can all be filled in by how many squares? If we don't reduce anything. How do we find the probability of winning? Add those diagonal regions. The 9, the 4, the 4, and the 1. We get? Oh, don't work it. Don't go from 64ths to decimals. 18/64ths. Then, now we could actually reduce 18/64ths, right? That'd become 9 32nds. Can that reduce?
No.
Doesn't seem like it.
Well, it can, but it won't be.
Well, okay, not nice.
My calculator.
Okay, so we now know what our total amount of wins is, right? Lisa, what was our original numerator for winning? 9, 4, 4, and 1, 5, 9, 18/64ths, right? We have 18 regions on there that win if we're working on graph paper. What's the probability that you got $100 assuming you had a win? Chris?
1/18.
How do you know?
Because it's assuming that you have a win, you're doing the 1/64th over the total chance of winning.
My regions of win become my denominator now. 100 winning. Is this all making sense? I feel like we got it, but sometimes I can do wrong. Is the conditional making sense? The given, how that changes your... Yeah.
Wait, what Chris said the answer was?
1/18. Because there are 18 regions that win. Right? So all of these win. But only this one is the $100. Now, we could actually do it the more complicated way of the 1/64th region divided by the 18/64ths, but still, when we do keep change flip and multiply by the reciprocal, we get 1/18. So it all depends on how you want to think it through. I'd rather you guys be thinking it through like this kind of visually, so it makes sense, but you can also compare the one probability to the combined probabilities. They show you the formula there. So that's just your probability formula. 8 minutes left. I'm trying to decide which one of these to look at. What do you want to do?
No, not 1 and 6.
It's a learning log.
Let's do 1 and 7.
No.
That's a good idea, yeah.
Yeah.
Yeah, let's do 1 and 7.
Let's look at 104. So check this out for a minute. Now we're working probability with variables.
I love probability.
Trying to extend you guys. One oh four. You might be onto something there.
I mean, if we have X in there and
What do we always assume? Sorry, we're running out of time. Sorry, to interrupt, but what do we always assume of our probability table when we're working with percentages?
Adds up to 100.
Adds up to 100. You sound like the dude from Moonshiners.
I've
Ever
never
watch-
seen that.
Okay. He's like backwoods of Virginia, I want to say, and he's got this really Appalachian accent. Now, 100% is really 1, right? So the area of this table is 1, which means its dimensions are essentially like 1 by 1, right? Now, if we imagine it to be a square, but again, don't trust what things look like, trust the math. So what's the probability of red? 1 minus x, right? Which means, can we fill in the table? Probably because I'm asking, right?
Yeah.
So, Colin made an observation that he felt like this was going to turn somewhat quadratic. What's the probability of blue and blue, spinning blue twice? X squared, right? Because the probability is x times x squared. What's the probability of spinning blue then red?
X squared plus
Minus X squared.
Ooh. Either x minus x squared, right, if we distribute, or negative x squared plus x.
I'd rather just X.
Same thing down here. What's the probability of spinning red twice? Taking that. It's quadratic.
it is.
squared.
But
Red twice, yeah.
X squared minus 2x plus 1.
Dang it.
This is fun.
The quadratic formula in there.
Now,
Not formula, equation.
this is gonna get real fun.
Fun for
Given
you to watch.
what?
Fun for you to watch.
Well, I do it with you.
Watch children.
You know what you're doing. So
Only kind of. My first year teaching math too was rough. Now it's like pretty comfortable. My first year teaching.
math was tough.
All right, we're gonna jump to D.
Oh, okay.
Given that the spinner lands on the same color twice, what is the probability it was blue both times? So how do we find our total region now?
X squared plus x minus x squared plus x minus x squared plus x squared minus 2x plus 1 equals 1. And solve for x. And then you find x.
Wait. Think about the given right here.
Oh.
What's our given?
Blue's x.
No. What's our given? Well, yes, but
Two colors. Red and blue.
indeed, yeah. But what's the given? We're
If they land on blue twice.
no.
Oh.
Close.
Wait.
Same color twice.
Same color twice.
Oh, okay.
The
Which
given is that we match. Our given is here and here. So I think you added too much. Because we just need to add x squared with x squared minus 2x plus 1. So our total region, no, x squared plus x squared. Remember the or adds. So 2x squared minus 2x plus 1. What goes over that? X squared. That's the probability of having gotten blue, assuming we won or got the same thing twice. We are out of time. Right, I believe so. That's at least on my schedule. Yep. So if you guys want to slip out here before 7th grade gets dismissed, you guys are headed to AO. We're headed to first
We're
one.
heading
And
to
IB.
the family room for IB.
Don't tell us about it. I'm not even going to kill
All right, have fun, peeps.
I don't want to. I don't want to.